Hi guys, so today we're going to start our triangle unit, and to begin with we're going to refresh our memory on the different kinds of triangles that we have to work with. So triangles can be classified two ways. They can be classified using their angles or their sides. The way we name our triangles is by using a triangle followed by the names of the vertices. So let's look at our triangles by angle. Now we are going to look here, and we see that this triangle has only acute angles, so we call it an acute triangle. 3 acute angles. Okay. Our second kind of triangle by angle is obtuse triangle, and it has one obtuse angle. Our third kind of triangle is a right triangle, and that has one right angle. And finally, for angles, we have a triangle where all three angles are the same, and we'll call that equiangular. Now, if we are going to classify the triangles by side, we have a triangle with all three sides the same, and we're going to call that equilateral. And the way we can tell that these three sides are the same is that we have our congruence markers. So there's one tick mark here, one tick mark here, one tick mark there. The next kind of triangle we have is an isosceles. This has two congruent sides. And interestingly enough, isosceles is the way we say same legs. So iso means same. And we put skeles means legs. So same legs. And our last kind of triangle by sides is called scalene. It has no congruent sides. Every side is different. All right, so we're going to use that information and identify each of these sets of triangles. So let's look here at our practice problems. Number 1 says triangle CDE. So what we're going to do is I'm going to have to recommend that you do a little bit of highlighting here, like often do here. So CDE is this triangle here. And that is a right triangle. We can tell that by that little symbol there. So this is a right triangle. Our next triangle is BCE. So let's go ahead and look at that one. BCE is right here. Notice I'm going in the order that the letters are given to me. I go to B to C to E. You may think it doesn't matter, but it will actually very soon matter a lot what order you go, you list the vertices. So BCE, and that is an obtuse triangle. ABE, and remember we are naming these by angles. So we have A to B to E, back to A. And that is going to be an equiangular triangle. All the angles are the same. Again, the way we know that is we have the congruence markings here. These arc marks are congruent. Next triangle they want us to look at is triangle BDE. So let's go ahead and look at that. B to D, over to E. There we go. And we can see this is an obtuse triangle as well. We see that the angle CED, that's a right angle, and BED is a little bit bigger than that. So that means this is going to be an obtuse triangle. And finally, CFE. We're going to be using similar logic here, only in reverse. Instead of seeing the angles as slightly bigger than the 90 degree, we're going to have one that's slightly smaller than the 90 degree. So you have C, F, E. And again, CED is a 90 degree angle, and CEF is smaller than that. So that is an acute triangle. Now we're going to look at these three triangles here and classify them by their sides. So our first triangle is JKM. So again, we're going to trace along the outside edges here. We're going to go from J to K to M. and again right back to J. Now, we can see JK has a single tick mark, KL has 2 tick marks, but NM and LM do not. That means they're not congruent to anything else. So we can see that JN plus NM is going to be different than any of the other leg lengths. We have KL and LM is also different than any of the other side lengths. And then JK is one of our side lengths that's marked. So because all of these are different lengths, these are scalene triangle. Up next is KLN. So again, start at K, go to L, go to N, and back up to K. We can see that KL and LN are congruent because they both have 2 tick marks. And so therefore this is an isosceles triangle. Finally, triangle JKN. So J, K, back down to N. We can see that JK, KN, and NJ are all the same length due to their congruence markings. And so this is an equilateral triangle. So again, we can classify every triangle 2 ways, by sides or angles, depending on what information is given to us. So for each of these, we're going to classify them based on what we are given. So this first example, we have a congruence marking here and a congruence marking here, and we see a right angle marking. So that indicates to me that this is a right isosceles triangle. And it doesn't matter if you say right isosceles or isosceles right, either way is fine. All right, the next one, there's no congruence markers, so we have to assume that every side is a different length, and we are given that one of the angles is 114. So that means this is an obtuse scalene. Our next one gives us 3 side lengths of 7 centimeters and 3 angles of 60 degrees. So this one is equiangular and equilateral. Our next example down here, we have a triangle that has 60 degrees, 74 degrees, and 46 degrees. And all 3 sides are different. So this is an acute scalene. Our next triangle has the right angle marking, but it doesn't give me any side lengths. So again, I have to assume the side lengths are different. So this is going to be right scalene. And finally, this triangle has 2 side lengths of 5 and an angle of 97 degrees. Since 97 is greater than 90, that does, of course, mean this is an obtuse triangle. And because 2 of the sides are the same length, it is isosceles. All right, so we're going to do one example of using algebra to find a missing side length. It says if triangle PQR is an equilateral triangle, meaning all 3 sides are congruent, and PQ is 18x plus 1, QR is 24x minus 17, and PR is 15x plus 10. They want us to find x and the length of each side. So what we're going to do is we are going to choose any of these 2 sides because they're all 3 congruent, set them equal to each other, and solve for x. So I'm just going to do PQ and QR. PQ equals QR. We do already have a list of givens, so we don't have to list them again. And PQ is 18x plus 1, and I'm going to set that equal to 24x minus 17. I'm going to add 17 to both sides, which gives me 18x plus 18 is equal to 24x. Subtract 18x from both sides, and that's going to leave me with 18 is equal to 6x. From there, I am going to divide both sides by 6, which leaves me with an answer of 3 is equal to x, or x equals 3. But again, it didn't only want x, it also wanted a side length. Again, since all the side lengths are the same, I'm actually going to use the 3rd side length for my x, just so I can put it to good use. So we have 15 times 3, and we're going to add 10. 15 times 3 is going to be 45, plus 10 equals 55. That was probably also the easiest one to work with. All right, so now what we're going to do is take a closer look at isosceles and equilateral triangles because they do have some special characteristics. First of all, we have the parts of an isosceles triangle. The two congruent sides are called legs. Again, remember I said same legs. The angle where the legs intersect is called the vertex angle. The side opposite called the vertex angle is called the base. And the angles along the base are called the base angles. So in this instance, angle 1 is our vertex angle, and angles 2 and 3 are our base angles. Our legs are side AB and BC, and our base is AC. All right, so here we have the isosceles triangle theorem, which states that if two sides of a triangle are congruent, then the angles opposite those two sides are congruent. So what that means is if there's an isosceles triangle, then the base angles are congruent. So the way we're going to write that mathematically, again, is if we have segment AB and BC. So if segment AB is congruent to segment BC, then angle 2 is congruent to angle 3. So the converse is also true. If two angles of a triangle are congruent, then the sides opposite those angles are also congruent. So again, mathematically, in the mathematical shorthand, we can say if angle 2 is congruent to angle 3, then segment AB is congruent to segment BC. So this does tell me this is a biconditional statement since both the original conditional statement and the converse are true. So we can say two angles of a triangle are congruent if and only if the sides opposite those angles are congruent. All right, so one thing you might have noticed as well up here when we were looking at our triangles is that our equiangular triangle was also equilateral. Well, that always happens. A triangle is equilateral if and only if it is equiangular. They always go together. So one thing, whenever you see that they say a triangle is equilateral, first thing you should do is go in and mark all three sides congruent. So AB equals BC, which is equal to AC. And you should also mark all of the angles congruent. So we have AB, or angle A, angle B, and angle C. And one thing to always remember, the angles are always 60 degrees. Now we haven't talked about it yet, but the interior angles of a triangle is 180. Since there's three angles, we divide that by 3 and get 60. So we're going to use that information and practice with a little bit. So we're just finding the missing measures, and they're asking us for angles on 1 and 2. And then for 3, it wants one angle and one side length. So looking at number 1, we have that JK is congruent to KL. Now they tell me they want me to find angle J and we want to find angle K. So this is an isosceles triangle. So angle L and angle J are congruent. So we can say that angle J is 68 degrees. And then to find angle K, we're going to subtract 68 plus 68 from 180. So minus 68 times 2, and we get 44. So angle K is going to be 44 degrees. And always use your degree symbol because remember that is our unit of measurement. Number 2, they give me that angle D is 106 and that CD and DE are congruent. So again, if two sides are congruent, then the base angles, or the angles across from those sides, are also congruent. So look, if I go from E straight across, I get to CD, and from C straight across, I go to DE. So again, what we're going to do is we're going to subtract from 180, but this time, instead of multiplying by 2, we're going to divide by 2, because now we're looking for the base angles. So we have 180 minus 106, and we're going to divide all of that by 2, and we get 37 degrees. So C and E are both 37. Number 3, it tells me that angle X and angle Z are congruent to each other. So that means that YX and YZ are congruent. So since it tells me that YX is 12 centimeters, that means YZ is 12 centimeters. And if they give you units, give back units. And to find the measure of angle Y, we're going to do the same thing that we did up here for number 1. And that is to take 180 and subtract the two 77-degree angles. So 2 times 77. And that is going to be equal to 26. So the measure of angle Y is 26 degrees. All right, number 4, we are going to use the information given to solve for X. So it tells me that these two sides are congruent, which indicates that the base angles here are also congruent. So I'm going to mark them as such. And then I can set my side lengths equal to, or my angle markings equal to each other. I'm going to say 8x minus 30 is equal to 5x plus 9. I'm going to subtract 5x from both sides, which is going to leave me with 3x minus 30 is equal to 9. And then I'm going to add 30 to both sides, which leaves me with 3x equals 39. Divide both sides by 3, and we get x equals 13. Same thing for number 5. We have two sides marked congruent. So that again indicates to me that these base angles are also congruent. Anytime you see the congruent markings for the sides, you should mark the opposite angles congruent as well. If you see that the angles are congruent, you should mark the sides congruent every time. So again, I can set these two expressions equal to each other. So we have 9x minus 33 will be equal to 4x plus 7. And I'm going to add 33 to both sides, which is going to give me 9x is equal to 4x plus 40. Subtract the 4x from both sides. And I'm going to have 5x is equal to 40. Divide both sides by 5, and we get x equals 8. Next one, we have ABC and a side length of 9. Now, they do give me that angle A and angle B are both 60 degrees. If two of the angles are 60 degrees, then the third angle is also 60 degrees. Because again, 180 divided by 3 is 60. So if two angles are 60, then there's only 160 left. So the measure of angle C, again, is going to be 60 degrees. And again, because this is an equiangular triangle, that means it is also equilateral. So that means AB and BC and AC are also congruent. So if AB is 9 feet, then BC is 9 feet, and AC is 9 feet. Easy enough. All right. Triangle JKL, we can see that it has tick marks indicating this is an equilateral triangle. Equilateral triangles are also equiangular. So let's mark the angles congruent. And again, if all three angles are congruent, then the only possible angle measure in this instance is going to be 60 degrees. So all three angles are going to be 60 degrees. All right, now using algebra to do this, it says if PQR, triangle PQR, is an equilateral triangle, solve for x and y. Well, this is fairly simple. We have 14y minus 59, 9y plus 1, and 11y minus 23. Again, this is an equilateral triangle, so first thing is we're going to set all three sides equal. And we're going to pick any two of these sides to set equal to each other because they, again, are congruent. So what we're going to do is I'm going to choose PR and PQ. Sorry, PR and QR because they're the smallest numbers. So PR is 11y minus 23, and that's going to be equal to 9y plus 1. All right. And then I'm going to subtract 9y from both sides, which will leave me with 2y minus 23 is equal to 1. Then I'm going to add 23 to both sides, and that will leave me with 2y is equal to 24. Divide both sides by 2. Therefore, y is equal to 12. Right, now how do I solve for x? They only gave me one angle measure. Well, again, it's equilateral, so therefore it's also equiangular. So we're going to mark these all congruent. There are 3 of them, and they're going to be equal to 180 degrees. So since we have 3 angles equal to 180 degrees total, they are 60 degrees each. So that means 7x minus 3 is equal to 60 degrees. And then I'm going to add 3 to both sides, which will give me 7x is going to be equal to 63. Divide both sides by 7, and that will give me x is equal to 9. So that's all we have on this part. So if I click the closed notebook, it takes me back to the front. I don't want you to click turn in on Kami, but what I do want you to do is go to your save button here and make sure you click save changes now. It's always a good idea to make sure that your most recent changes were updated so that I can still see them. In Google Classroom, turn this in and we'll attach it to the next assignment as well. For now, that's all I have, and I'll talk to you later. Bye.